There are approximately 7.5 billion people currently living on Earth. Most activities we do require energy, and with this growing population, our demand for energy is projected to rise. The population is increasing at a rate of 200,000 people per day, and our daily current energy usage is roughly 400 terawatt-hours. But that is also increasing. To put that into perspective, 1 terawatt-hour roughly equals 600 barrels of oil. This increase is partly due to the fact that on top of the energy demand from developed nations, demand from developing countries is increasing exponentially to support their growing economies as well. At present, 86% of the world's energy produced comes from non-renewable sources. For example, coal, oil, and natural gas, all of which are sources of carbon stored within the Earth for significant amounts of time. When these carbon sources are burned, CO2 is released into the atmosphere and contributes to the increasing number of greenhouse gases. At over 400 parts per million of CO2 in the atmosphere, we've already seen the negative effects of using these non-renewable energy sources. This is causing adverse effects on our natural environment, and the changes are quickly becoming irreversible. The main solution to this problem lies in utilising renewable energy sources.
The more well-known renewable energy sources, such as solar and wind, have been in use since the 1800s, but there are many other advances in their respective fields. While the initial costs of both are rather high, they quickly pay for themselves with minimal upkeep costs. Switching to 100% reliance on renewables is the best way to ensure a sustainable future. While this seems like a daunting task, considering how much a society relies on non-renewable energy sources, countries such as Costa Rica have proven that countries can run on all renewable energy. In 2016, they ran exclusively on renewable energy for over half the year. Costa Rica is a small island country, so when expanding this out to larger countries, such as the US and UK, new issues come into play. Much of our infrastructure is tied into non-renewable sources, and most of the companies profiting from this are not supporting a transition to green energy, as evidenced by all their lobbying against climate change measures. Luckily, the market is shifting towards renewables, as evidenced by powerful countries' devotion to them. Due to their high investment, China recently took over as the biggest producer of solar energy. In the US, the solar power industry employed 55,000 more people in the last year than oil and gas combined. A key contributor to this is Tesla and its CEO, Elon Musk, who are currently finishing construction of their gigafactory. This will help solve the problem of storing energy generated by solar panels on a larger scale. The amount of energy and batteries that this facility and those like it will produce is set up to help push the automobile market and the overall energy market towards using renewables as a primary source. Wind energy has also been growing steadily as turbine use is increasing at a rate of 25% per year according to National Geographic. Not only can one turbine power hundreds of homes, but they have been shown to be able to mitigate the power of tropical storms if placed in coastal waters. Despite turbines only providing a small portion of the world's energy, the future is bright for them, with many governments promoting them by law as evidenced by the Paris Climate Agreement. If this trend of wind energy continues, it is projected to contribute a third of the world's power by 2050. Hydroelectric and geothermal energy are also viable sources of renewable energy and can be expanded upon in the future. All of the previously mentioned energy sources have come from abiotic sources. While not as developed as their abiotic counterparts, there's a whole other group of renewable energy that could be generated from biotic sources available.
Utilising the life around us for energy is not a new concept. Gasification is the process of producing fuel gas from burning biomass. This process has been around since the 19th century and still functions as a valuable power source for developing communities today. The process can use many different sources, but is only considered renewable if it doesn't use non-renewable sources. Since it usually burns wood and plant material for fuel, carbon-neutral energy production takes many years to achieve, since the carbon fixation activity from the vegetation is lost to create energy instead. Other more efficient methods have been developed that take advantage of agricultural and waste treatment processes. Fossil fuels have been used extensively since the start of the Industrial Revolution, and is a main contributor to the current atmospheric concentrations of CO2. Recently, biofuels, fuels utilising renewable biomass as an energy source, have been developed and hold great promise for the future. Some examples of commonly used biofuels are bioalcohols, which are collected from wheat, corn, sugarcane, molasses, potatoes and fruits. The main advantage of biofuels is that they are approximately carbon neutral. In our current energy landscape, the transportation and production processes still use non-renewable sources, but the actual process of planting crops, producing biofuels, and then planting the crops again, effectively cycles the carbon that is released when the biofuel is used.
Almost everything we do produces waste of some kind. In the case of wastewater, we can't just throw it into landfills. Instead, it needs to be treated in order to be put back into the natural cycle. This purification would normally require energy. However, energy can be generated from this process instead. One way in which this can be done is by using microbial fuel cells. The basic process relies on microbes oxidizing biodegradable compounds within the water in an anaerobic anode chamber. The protons and electrons produced flow through different routes to a cathode chamber and react with oxygen, producing clean water at the cathode and inducing an electric current. The power generated from an individual fuel cell is not yet suitable for large-scale power application. However, it is ideal for allowing more small-scale devices such as biosensors to be self-sufficient. According to work done by Merritt in 2010, this process can also be used beyond generating electrical power. By dividing the cell into 3 chambers, with the central chamber containing salt water, the process can actually be used to desalinate this water. Instead of allowing H+ ions to transfer, the charge is balanced at the anode and cathode using the sodium and chloride ions in the salt water, passing through a CEM or cation exchange membrane. By using the ions in the salt water as a terminal electron acceptor instead of hydrogen, hydrogen gas is released, which can be further used in hydrogen-powered cars or fuel cells to provide electricity.
While microbial fuel cells are useful for more small-scale applications, there are other ways in which waste can be utilized to create energy on a larger scale. The process of anaerobic digestion enables us to convert organic waste into useful biogas utilizing methanogens as the driving force. First, organic waste is collected from agriculture, human activities, and other sources. Microbes then break down the organic waste in a closed system. The gas is then collected. The biogas itself is 60% methane, 40% carbon dioxide, as well as other gases in trace amounts, mostly hydrogen sulfide and ammonia. This gas can then be used for electricity, heaters, and transportation, allowing us to decrease our reliance on non-renewables. The leftover biomass, referred to as digestate, can then be used for fertilizer as well. This process provides clean, renewable energy, but also utilizes a normally unused link in the cycling of carbon as an energy source. The gases still end up in the atmosphere and exacerbate the greenhouse effect, but the more we become reliant on green energy, the more effective it will be. Additional benefits would be reaped in the form of the high availability of natural fertilizer by virtue of the digestate created. Just like any other fertilizer, use must be monitored in order to avoid nutrient loading and runoff, which is detrimental to many aquatic systems since it can lead to eutrophication, among other things. At current projections, biogas has the potential to produce at least 25% of our renewable energy, an encouraging number for the future of energy production. Funded by the Bill and Melinda Gates Foundation, omniprocessors provide another way that waste can be recycled for energy. With providing renewable energy to developing countries in mind, this system has different variations in how it runs, but the main goal is to be self-sufficient and function as clean waste disposal. An example of one type of process is shown with the Janicki omniprocessor. In this system, waste biomass is first heated and then burned to create steam to power a turbine for energy generation. While this occurs, some of the steam is redirected back to run the heating process where the excess is filtered, and then eventually becomes clean drinking water. This multifunctional process, and those similar to it, will help to greatly increase the efficiency of our waste disposal and reduce the amount of clean energy generation opportunities that we are currently missing out on.
Renewable energy sources have shown to be viable at small scales all the way up to powering entire countries. All we need to do is continue investing and developing them. The Renewables 2016 Global Stats Report has shown that the developing world has surpassed their welfare counterparts in renewable energy investments, emphasizing how the world is already transitioning to renewable sources. Recent research has already shown how versatile we can be in producing energy, from using the crops we eat to the waste we produce. There is many steps that can be exploited for energy production, and various microbes have been shown to function as biocatalysts to make these processes even more efficient. At the end of the day, how we leave this world is how we will be judged by the future generations. However, in order for that judgment to be positive, the wealthy countries such as the US and the UK need to go all in on renewable resource use to ensure we do all that we can to reverse the detrimental effects of industrialization.